right, people came late. Do the quiz. All right. So yeah, please go do the quiz if you haven't. But wait, it's not. Yeah. So go do the quiz if you haven't yet. But I'm gonna move on. Hello. All right. So I want to keep talking today, and today the aim is to actually finish talking about all the basic rules that govern how C works in the same way that kind of whatever multiplication, how you deal with parentheses and so on, has been dealt with in like grade 5 for arithmetic. And then for a while, what we're going to do is we're just going to do exercises. Like I said, like knowing what addition is, knowing what multiplication is, it's not enough to really understand algebra. You got to just get used to it, right? So so that's kind of after the famous quote from I guess John von Neumann. So you don't understand quantum mechanics, you just get used to it. So kind of in the same way, but easier is with pointers in C. So there's going to be lots of exercises, but we still have just a few things to cover in terms of the rules. So first, we already mentioned this, but I'll now do it formally. So what's the difference between arrays and memory blocks? Sorry, can I get a little bit more quiet? People made friends with their neighbors or something now. And my hope was that like in my hole 150, the string on the chair makes you turn towards your neighbor. But here, if you turn around your neighbor, it like breaks your neck. So bad for your health too. Don't do it. Okay. Your neighbor is not that interesting. Okay. So arrays versus memory blocks. So if I'm inside the function like that, I can define an array. So let's say 20 integers, whatever. I can, in principle, here say return array. So because it gets converted to an address of int, now it's going to be int star f. So that means that f returns an address of an int. So specifically, f would be returning the address of the first element of this guy. I can do it. The problem with it is if I now go outside and I say something like this. So let me retype it for the people who are typing. If I do something like this, that will compile, that's fine. But if I now try to say p at 0, that is undefined behavior. And the reason this is undefined behavior is that the array here, it's a local variable. So there is an address of array at 0, that's still a number. But after the function f has finished running and returned, that address is an address of a local variable that's now gone. So you could try to access it, but it's unpredictable what's going to happen. It might be that it's still the old value. So maybe we'll set the old value to something specific. It might be that it's still 42. It might be that you even get 42. It might also be that this memory that used to be used in order to store array is just not there anymore. You're not allowed to access it, and then your program would crash. And sometimes it would be this, sometimes that. That's what undefined behavior means. So you should obviously never have programs that involve undefined behavior because, again, your computer might get set on fire. Yes. Okay, so that's a good question. So it is not despite appearances star f. It's int star f. So f returns a value that's of type int star. And then the reason is that when you say array, that's converted to the address of the first element, which is an address of an int, type int star. Right? So again, undefined behavior. So might crash, often will crash, might sometimes print 42. All right. On the other hand, if you are using malloc for this, so f was like bad, so I'm not going to name it anything. But if I make a function, and I'll call it like make block. So Copilot is suggesting something bad now, so that's good. It's not perfect. So it's suggesting doing the same thing. Not how you can do it. You can, however, say, no, Copilot, bad Copilot. So here you can say something like, I want to allocate this much space, so enough space to store size integers, and then I'll return p. So malloc returned the address where I can have the first element of my block of size integers, and I stored that address in p, and now I return p. So the function make block gives me back an address that I can use in the same way that malloc does. Yes.
You pass the malloc to an int star?
Oh yeah, to avoid the warning, yeah. So like it would work, but yeah, you're right. Thank you. So yeah, so and let's name this like make block of ints. So I can now say int q, sure. And then completely like q at 7 is equal to 50. That's cool. All right. So this is kind of not conventional. People don't do this. You might imagine just making those several functions like make block of ints, make block of floats, like they're in a way more convenient to use because you don't have to cast every time or make block int definitely returns int star. That's in the definition. You know. You can do it. And in fact, like, since you're doing it, you might as well say, okay, like malloc sometimes doesn't find the space, like if you don't have enough space. And the way it indicates that it failed to do anything is it returns 0. So if malloc returns 0, that means that it didn't find a space. 0 is not a real address. If you try to then go to address 0, the program will crash. So since you're making this function, you might as well say, okay, like I'll do something kind of sensible if this failed, right? So you might say, so if p is, so null is just defined as 0. Usually when people are talking about memory, they say null. That's defined in stdlib. And you might say out of memory, for example, and just crash anyway, but at least you crash with a message that says out of memory. Exit 1 means exit the program. So if a user uses the program, what the user will see is, well, the program terminated and printed out of memory. That might be preferable to crashing in other ways because sometimes a program crashes and takes the entire computer down with it, right? So like sometimes you have like whatever, like Chrome just freezes your entire computer. Happens to me, right? So here, at least it's kind of like crashing, but in an orderly manner. You might imagine other ways of handling this, right? So like you might imagine returning, well, you can't return a special value from make block int because the only available special value that you could have is 0. And then if you return 0, you're doing the same thing as malloc, so that's pointless. you might imagine like setting a global variable that to indicate that something went wrong and checking that global variable. That seems like bad practice, but in C it's more acceptable. And people do that. So multiple things you could imagine doing. So here, just for the sake of the example, you could do this. People don't usually have those like custom make blocks events. If you find yourself needing to make those custom functions and thinking that they're useful, well, like maybe you didn't want to program in C in the first place and like pick some other programming language that does this kind of housekeeping for you. The idea for C is like, you know, like save on everything, right? So like instead of checking whether malloc returns 0 and doing something special, just return 0. And like if you care, you can do something, but C itself is not going to do anything except return 0. And that's kind of because sometimes you're in such a rush that there's no time to check whether the address, you don't want to do the extra if statement that checks whether you found the address or not. That's why it's like that. So, okay. And to be clear, like if you are in a situation where you might run out of memory and you don't check, the program will crash if you try to access a 0 pointer, right? So not, so, okay. Makes sense? All right. So that's malloc. And that's kind of memory blocks. So with arrays, you could not do this. So arrays are basically for if you need a block of variables that is not too large and that you only are going to use as a local variable inside the function, then you might consider an array. For anything else, if it's like a block of integers or something, you should probably be using malloc. And if you need to return this outside the function, you definitely need to use malloc. Arrays just won't work for that. Another use of arrays we'll see in a second when there are inside structs. So, okay. So the other aspect is in Python, when you create an object, you don't care, like you stop using it at some point and Python at some point will clean up after you. So it's not going to occupy the memory forever. In C, it's not like that. So in C, so the way I would put it, it's good practice after you know that you're done with the memory block to free it. It's not strictly mandatory on a modern operating system, and I'll explain what I mean by that. So while the program is running, if a block is malloced, that means that it's reserved for the block of memory that you reserved it for. Obviously, you cannot malloc the same thing again for some other purpose because there's only one area in the memory table and it's already being used for something. So if a program is running continuously, and actually like a lot of programs are running continuously, so notably Windows is running continuously, OS X is running continuously, like until you have to restart them, right? So in this kind of program, if you keep mallocing and you never free, at some point you're going to run out of memory, right? For the kinds of programs that we've been writing, which are not meant to be running continuously, on a modern operating system, you can say whatever, like after the program finishes running, actually automatically it will be the case that whatever was malloc is going to be freed up. On older operating systems, and you might imagine like if you're running like an embedded something where it's like an operating system that kind of doesn't do the extra stuff for you, like freeing up memory blocks that you allocated because you know, it's trying to be economical, that might not be the case, and that might cause memory leaks. So a memory leak is when space was allocated for a program, but it was never freed, and that means that no other program and no other sub-process in the current program can use that memory. You have too many memory leaks, you run out of memory, your computer freezes. In fact, like that is a situation that occurs some of the time that your computer freezes. If it does, that's because there was some memory, there was like accumulating memory leaks and it ran out of memory to allocate. You had a question?
Yeah, I was wondering if you could just go over why you can't use arrays again?
Yeah, so the issue is that this array exists as a local variable. It does have an address, but it's a local variable. After the function has finished running, you're not allowed to access local variables. So that address as a number, it still exists. You can try to go to that address. It's just that it's undefined behavior.
So if you initialize the array and there's a value at that address, is the value still going to be there? It's going to just...
I mean, the value, so whether I initialize or not, there's going to be something there. It's not that it disappears, it's that it might get reallocated for some other use. And when it's reallocated for that other use, like whoever's in charge of that memory area then can go and kind of rewrite it or keep it the same or not let you access it. Makes sense? Yeah.
So using the arrays in a global sense, arrays versus malloc, what would be the difference in like using global?
Well, so one difference is so the other difference between so like for one thing, you're not supposed to do that. So like you're not supposed to have global variables. It is true that if you have like a global array, then yeah, like it's not an issue that it disappears after a function finishes running because it's not in the function in the first place. And now other issues are you cannot resize an array. You can, although we haven't done it yet, resize a malloc allocated block. So, okay. All right. So here's an example. So you can malloc a block. So in this case, I mallocked a block of 100 ints. And then I can do whatever I want with it. And then after I free it, there's not anymore a memory leak. Accessing block at 0 after you freed is undefined behavior. So it's not that the value of block changes. So block used to be an address. After you free it, it's still the same address. It's that you said to C, I'm not going to be using it anymore, which means that C can decide, not C, the program can decide to do whatever it wants with that address, including restricting your access to it, including changing the value. So accessing block at 0 or block at 1, whatever, after you freed block is undefined behavior. All right. All right. So one last thing I want to talk about with respect to the rules is blocks of structs. So block, I use kind of a generic term for both like an array and for a block that's malloc allocated, where you have several of the same kind of thing in a row, basically. So here, for example, so I've defined a string, and the string in it has a 200 character name, well, 199 character and a null at most, and then an H. And you can define an array of students like this, right? So we say students 500. So here, student is the type, right? So the type def allows us to say, I have this new type of variable and it's named student. And then students is just the name of a variable, same as anything else. It could also be like array or whatever. And then I said, I want 500 of them. Or I can say, I want a block, a memory block where I can store students. So I'll define a variable of type student star. So a variable of type, this is the address of this kind of structure. And then the name is students block. And then on the other side of the equation, assignment statement, not equation, it's the same, right? So I tell malloc, give me enough space to store 500 of those student structs. So that's 500 times size of student. Size of student is how much space do I need in order to store one of those? And I need 500. Then cast it to type student star, and that's students block. So using those then would be the same. So students at 0 would be the first student defined as an array. Students block at 0 would be the first student in that block of students. Make sense? Questions? Yeah.
Does the type def need to be in the main block or outside of the main?
Well, there's no main block in Python at all. So it would be outside of a function generally. No, this is C. So that's why there's no main block. You're asking about main function?
Main function.
Yeah. So that would be generally outside of any function.
This type def.
Yes. Well, you can make it be inside as well, but then it's like just inside the scope of that function. So generally it would be outside of anything so that you can use it in multiple functions. Right? So the other stuff, technically it's application of rules rather than new stuff, but might be a little bit gnarly. So strings. So we had two ways of defining strings, right? So one is an array of characters, and one is the address of the first element of a block that happens to be characters, right? So here I'm defining S1 as high. So remember that's the same as literally the same. And here I'm saying I'm having a variable whose name is S2 and whose type is address of car. Make sense? So here's something I can do. So I can say S2 is equal to S1. So what this does is same as in Python. S2 is now an alias of S1. As it happens, not a big deal that they're aliases because you're not supposed to be modifying the contents of S1 anyways. But this is aliases. This right now you cannot do. So strcpy from wherever last week, right? So strcpy is saying take the contents of S1 and copy them over to the address starting at S2. You cannot do this at this point because S2 is not a valid address, right? So this is basically S2 didn't initialize it. So S2, the value of S2 right now is some random garbage. Then this is saying go to address some random garbage and put S1 at 0 at that address. And then go to some random garbage plus 1 and put S1 at 1 there. You're not allowed to go to address some random garbage. So sometimes you would just initialize with 0 if you don't know what to say. Again, you're not allowed to go to address 0. So this would not work. So to be clear, so what is this? This is the same as S2 at 0 equals S1 at 0, and S2 at 1 equals S1 at 1, and so on. So are people good with the distinction between S2 equals S1 and strcpy S2 S1? Who is not clear in this? Who is clear in this? That's like less than half. Okay, so again, S2 is an address, right? S2 starts out as 0. So it's an address in the memory table. In principle, it could be any address. We set it initially to 0 just because. 0 is not a valid address in the sense that you're not allowed to put something at address 0 just because you want. All right. S2 equals S1 says S2 is a variable that stores an address. Now make this address be equal to S1. S1 actually is a valid address. So now S2 and S1 store the same value, and that value is the address of the hive. Does that make sense? So this is what S2 equals S1 does, is S1 is the address of the hive, and now copy S1 to S2. So now S2 is also the address of the hive. So to make it concrete, if high is stored at addresses 1032, 1033, 1034, then the address of the H is 1032. And S1 gets converted to 1032. So it's an array, it's not exactly an address, but when you use it, it gets converted to that. So S2 equals S1 makes it so that S2 becomes 1032. So this is different. This is not saying so this is not saying go and copy like set S2 to be equal to S1. This is saying go to whatever S2 is and copy S1 at 0 to address S2. And then copy S1 at 1 to address S2 plus 1, and so on. So if S2 doesn't start out being a valid address to which you can write, that's a problem. Okay. And the difference is between just saying I have a note with I have a note with the address of my office. I can copy that address to another note. Now I have 2 notes, both of which are the address of my office. On the other hand, I can say I have, and this is strcpy, so there is Bain 2028 and there is Bain 2026, and you can say, go to Bain 2028, take a book from there and put it in BA 2026. So that's analogous to strcpy, right? So go to that address, bring something over from that address to a different address. That's strcpy. And this might kind of illuminate it as well. On the other hand, this is just saying, well, take, like I have this note, it has an address written in it, copy it to the other note, the address, right? So now I'll have 2 notes, both of which say BA 2028. So here's what you can do. You can say, okay, I want S2 to store the address of a memory block to which I can write. So I say, I have this note. No idea what this is. So I have this note, and I want you, malloc, to write an address on this note, which would be a valid address to which I can go and write a string there. Right? This is this line. And then this note is S2. On this note will be an address where I can actually write stuff. So once S2 is a valid address, then I can say, well, go to S1 and copy the contents from S1 to S2, now to the valid address S2. Make sense? Yeah.
Does that also work?
Yes, if you declare S2 be an array, yes. Now you cannot exactly make it into an array, you have to declare it as an array. But yes, like if you here said something like car S3 5 or something, then you can go strcpy S3 S1. And that means copy the string from S1 into S3. Make sense? Cool. All right. So that is strings. And then I want to do one more thing, and some of you have seen it in the lab. I actually I went into the lab on Monday and thought better of it. Well, like it wasn't supposed to be in the lab, but it kind of was one of the interpretations of the lab, and then I took it out for the people on Wednesday. But don't worry, Wednesday people, you will not miss out. You'll have it next time. Yeah, I had a question.
Yeah, I assume the last part, we use 39 S1 plus 1. Is that?
Oh, yeah.
The null characters?
Yeah, exactly. Yeah, thank you for bringing it up. So yes, so in order to have enough space to store the entire thing, so the entire S2, you need as many characters as there are in the S2 plus the null character, which says that everything has been terminated. If you can't copy the null character, it's a problem, because if the string is not terminated with a null, when you try to print it, C is going to try to go and find the null, probably ending up, well, for one, printing a lot of garbage, for two, possibly never encountering the null before trying to access an address that it's not supposed to access, and just crash. So, okay. All right, makes sense. Questions? Other questions? All right. So last thing, so some people call this double pointers. This term is banned in this class for reasons that I'll explain in a second. So here's how I would like to think about this situation. I want to be able to set to 0 a value that happens to be an address. Right? So maybe what I want, so maybe I have a pointer PA over here, and this pointer happens to be the address of A. And I want to send it to a function and set PA to 0. Right? So what I'm trying to do is I'm trying to set this variable PA. It happens to be of type int star. I want to set it to 0. How can I do it? Well, I need to tell the function, okay, I have this address, go to this address and set the value there to 0. So what's the address I want to say? Well, I want to tell set to 0, PA lives at this address. Go there and set that to 0. So the type of the value address of PA is an address which happens to store a value which is of type int star. Right? So it's an address of a value which itself happens to be an address. In other words, PPA here, it is the address of the variable PA. It also happens that PA is itself an address, but that is not important at this point, right? Because all I want to do, nothing to do with A, I want to set the value of this variable PA to 0. That's what I want. And then I reason back. Well, PA, it's of type int star. What do I need? What kind of information do I need in order to set the value of PA to 0? I need the address of PA. What's the type of PA? Well, it's int star star, because PA is of type int star. The address of that must be of type int star star. All right. So set to 0 works exactly the same as a function like the swap function and whatever set to 0 for integers that we had. The only thing is it gets the address of a variable of type int star. And then same thing, go to that address, set the value to 0. So again, how would we write it for integers? Like this. What did we write now? This. It's exactly the same. Like you get an address, you go to the value at that address, you set it to 0. The only thing is that when I want to set a value of a variable that is itself of type int star, what I got to do is I got to send the address of that value, and that address is of type int star star, meaning it happens to be an address of the value that itself happens to be an address. But this and this, those are exactly the same. And that's because they do the same thing. I get an address, go to that address, put a 0 there. So I think the way to make sense of this is to think about it like that, right? So I have a value which is of whatever type, happens to be int star. I want to send the address of that value. What's the type of the thing that I'm sending? Well, it's int star star because it's an address of something that happens to be int star. People sometimes talk about this, oh, it's a double pointer. I think that's an extra step in the story that's already quite complicated. That's not actually helpful. Sometimes you have those mental shortcuts where you call something a thing, and it helps because you have kind of patterns of how you deal with that particular kind of object. So an example of that in Python is like mutable objects, immutable objects. As we now know, it has to do with constant stuff like that. And those shortcuts also sometimes break. So that's why people usually don't do that well on the output prediction task in the ESC190 stuff. Actually, like knowing that something is mutable or immutable doesn't tell you the whole story, right? But with double pointers, it's like especially bad because I just don't see a use for thinking about double and single pointers. I think if you just reason through it and say, okay, what is it? It's an address. Sometimes you would say an address of an address. Sometimes you would just say an address of a value that's of type int star. And that actually helps you think about it, in my opinion. All right. That is it. Those are all the rules. So at this point, we're switching to doing a little bit of exercises. I'll do some of them in class. Some of them I'll leave for you to do. So I made a bunch. So I call it my pointer drills. And there is, I don't know how many, 45. Maybe we'll make some more. They're short. They're not like, yeah. And it's like, again, kind of the idea is in the same way that, well, like you are in exercise, so you must have gotten good at algebra at some point, and it must have involved doing exercises. It's the same with pointers. Like, just got to get used to the rules. So okay. So this one, I would say kind of during lecture, it doesn't, I'll just, yeah, I like made this thing. I'm very proud of the buttons. So yeah, and you can, there is also like a show solution button, but don't press it. So yeah, so that's kind of just like warming up. Okay, so like integer variable initialized to 42, well, that's this. So integer variable PA, initialize it to the address of 8. again, I think so. I'll just show you, and I think like, but if you feel like okay, like I wouldn't remember now how to do it, it makes sense to go back and try to do it at home as well. But this is like this, right? So again, you are defining a variable PA. The type of PA is in star in the same way that the type of A is int. And then we're initializing it to be the address of the A. All right. Again, kind of this notation, I find it useful sometimes. There's limits to it, and we already kind of brushed up against those limits when I was showing you this thing, right? So if I have an array students, like obviously students is going to get converted to a pointer, but it doesn't make a lot of sense for me to call it p students, because like that's not how you do arrays. On the other hand, with student star, student block, well, you might argue, oh, that should be like p student block, but then you break the symmetry with students, right? So like, why wasn't there a p when you were defining an array? And that's kind of, there's no solution here as far as I can figure out, as far as anyone else, I think. So kind of when it's useful, I'll use this p notation. When not. At the end of the day, it's always just a name. Okay. So using PA without directly using A, change the value of A to 43. So the idea here is that PA is the address of A. So if I go to that address, so if I go to star PA, I can set star PA to something new, right? So this would be star PA is equal to 43. Change the value of the pointer PA to something else and make it so that the value of A does not change. So this is the story with a node that says ban 2028. You cross out 2028, you write something else. The contents of the office do not change. So this is like PA equals 0. Wait, yeah. Or in this case, I kind of went all out and say, I want PA to be the address of this new variable B. The key point here is the assignment is PA equals, right? So if I say PA equals, that means PA used to store the address of something, and now I want PA to store some other value. So orally, I said PA equals 0. Here I said I want PA to be the address of B, used to be the address of A. Now I want PA to store the address of B. So a function that takes in a pointer to an integer and changes the integer. So that's the set 0 example that we have just done. So I'll just show that. So take pint that's of type int star, set the value at that address to 45. So that's star pint equals 45. Again, I want to draw your attention to the fact that the star here and the star here, those are separate completely. In fact, this star is part of the type int star. So pint is pint. It just happens that it's of type int star. And then star pint means go to address pint and get the value there. So one is defining a type. The other is an instruction to go to an address and do something there. So conceptually related in the sense that both have to do with addresses, but that's the extent of the connection. All right. So call the function Q5 to pass in the address of A and make sure that the value of A changes. So what I want to do is I want to call change int, and I want to call change int in such a way that changes the variable A. if I want to change the variable A, the only way for change_n to accomplish that is if it knows the address where A is, so that it can go to that address and change the value there. So that means that change_nt would take the address of A. Right? The other way to think about it is the type of A is int. The type of address of A is int star. The type of address of A must match the type of pint for anything to compile at all. So address of A is actually the only thing that C would allow you in this case anyhow. All right, so if you feel like you couldn't answer those, I would suggest that you go over those things again instead of listening to like whatever people at ESC are going to tell you. And otherwise, I will see you Monday. Thank you. Yeah.
Why is it like P int? Shouldn't it be like A only?
No, so P is just a name. This is arbitrary for one thing. So by convention, I name things P int if what this stores is an address of an int. But this is just a name. It could be anything.
So what is like P int is equal to
Whatever. It's a variable.
like P int has a
It's a
pointer
variable.
in it, or it has a pointer.
No, so pint is a variable that's of type int star, right? So type int star means that pint is an address. What it stores, well, whatever, like when the function gets value from outside, nothing's guaranteed. So the intent here is that you can call it like this. So you can say pint is going to be the address of A, so that then you can go to that address and modify it.
And here when you we can't use malloc with S3.
No, that's a separate.
Yeah, but
So
like,
because it's S3, it's an array, so you don't need to use it. So malloc is for allocating new blocks of memory. Arrays are allocated automatically.
and when I use state copy for like here I have given an array of size 5 and like S1 is of some another size, then what does this tell me?
So string copy, if you look at the example from last week, it copies the contents of the string. So this string is of length 2. So it just copies whatever is the string. It doesn't look at the size of the impacted count. Yeah.
I was doing login today, and for the question, I tried like making it like as simple as possible.
Okay.
And I realized that there's a difference between increment and source length here.
Yeah. Yeah.
And I didn't get why.
Like
this over here.
Yes, that's undefined behavior. You're not supposed to do that. So this is undefined behavior.
Undefined behavior?
It is.
Does the thing mean that
It doesn't mean anything. It's undefined. So you cannot use so specifically kind of plus and then also using expressions involving the same variable is undefined behavior. So undefined means it sometimes would work, but undefined.
Yeah. I don't know.
No, like it can work out, but it's undefined.
Okay.
Yeah.
So like on like a quiz or exam that was gonna be wrong.
Well, if you catch it, then,
Yeah. Okay. Because I thought like it was supposed to be before the before expression. And after expression was different, right?
Yeah. That is true, but so that is true. So plus after means
after
you
the
use the current
expression.
one, the current value, and then you increment. Plus before means you first increment and then, but then what you are doing is like related. So there could be a definition for what it is, but as it happens, this is undefined. Yeah.
What exactly does this do?
So this, you need a semicolon. So this defines defines a structure, right? So if you go to, I think Monday, so this allows us to define a new type of variable. So we name it student. And then for student, we can access the name and we can access the image.
Is there using type student again on line 94? What it is?
Yes, so by default, so you can not have the type def, and then you can just have struct student, but then the type would be named struct student, and you would have to repeat struct student everywhere, which you could, but it's
Question.
more typing.
If I want to like do access the variable located at the original string, why do I have to put a bracket around the like
You don't.
you can directly write, you can just directly write that and it will work.
Yep.
Oh,
I mean, I don't know if it would work in other ways, but like the parentheses are not necessary.
because I ran it out I ran it out home, right? It didn't work. It said
Uh,
completion error.
So different reason. The parentheses were not doing anything.
Okay.
So if you sometimes get segmentation fault, that's likely because you have undefined behavior somewhere.
Okay. Yeah, but also it's kind of weird in labs. Like if you don't put a space in front of the scanf,
That
Just the
is true, but
segmentation.
unrelated. So that is because scanf, which I kind of regretted putting on the lab and took out actually for the Wednesday one. So that is because of the enter. So when you tell scanf, I want to get a character, and then scanf stops input when you press enter. So you get a character, and then there is also an enter. So the next character would actually be read in as an enter if you don't have the space. So the space before the character means ignore white space. So basically ignore the previous enter.
Okay. Okay, thank you.
Sure.
I have a question for like pointers. So like this above is like what you showed with int and int pointer and like the double pointer. And to my understanding, it's like if I do like after like I do like double pointer change, if I like print PA will give me 0, and if I print like the value stored in PA will give me exactly.
Yes.
So is it the case there where the type of PA change from like
No, that's there is no such thing as change in the type. It's that PA 0 is not a valid address. So trying to access an element of 0 just makes no sense because not accessing a valid address.
But like if I do it with like character here, so PA like the BA here is like a character pointer.
Yes.
And then if I do the change, BA seems to become like a character. Because if I do like BA, it gives me like the A, which is like changed.
Yes.
So yeah, so like I'm not sure how it works. It seems to me like it's changing type.
Well, so it's not exactly changing type. So here what happens, it's kind of the other way. The type doesn't change, but you're saying interpret it as a character, right? So here you're giving BA. So here you're giving BA. So BA is whatever 10,032. And then you're saying do your best at pretending that it's a character, and that's what it does. This is undefined behavior. It could be anything.
So like this part is like a bit like undefined behavior.
Like this
Okay.
is, yeah. So because like you're trying to interpret something that's really an address, like 1032, more likely 1032,500,000, whatever.
Okay.
And you're saying, well, pretend it's a character. Do your best.
Okay.
So that's what it's doing.
Okay.
So this is the normal thing. You're printing the character as address BA.
Okay, get it. Thank you. That makes more sense.
Sure.
I did the online lab.
Okay.
I was just wondering, like I tested it in Pain.
Okay.
I was wondering when I submit it, do I get rid of the tester functions or do I?
Doesn't matter.
Okay, like I just this stuff doesn't matter. Kind of.
So like it would be more, so for projects, we'll actually ask you to remove the main.
Okay.
For this one, we won't, just because I actually don't want to uncover. So here's the thing, like if you have a main function, the only way for us to run your code is to actually manually remove your main function and then run it, because to run something, you have to have a main function, it can't be yours. But at the same time, for the online exercises, I really want to I honestly don't care what people do there, as long as like they just made sure that they've run the thing on their own computer. But I feel like forcing people to like remove the main kind of encourages people to just like copy and paste the ChatGPT, and and they want to do the opposite of that. So for that reason, I didn't ask for people to remove the main. So what we'll do with the auto grading is we'll just manually, not like manually, but the program will just get rid of your main, then we'll compile with our own main.
I was just wondering, because it said like you want to compile it on your then that work.
And the answer is like we'll like our script will just get rid of the main.
Right. Also, I want to say I tried taking your class last year, but then I got a concussion. So I'm in it again, but I think it's really improved, like the pointers, and I don't know, I feel like the way you're teaching is.
Thank you.
Just a nice thing to say, but.
Thank you. Yeah, thank you. And I hope no concussions is better. Yeah.
I was like kind of reading about like what you've done, like where you are.
Yeah.
And I'm kind of like interested in, I guess, algorithms and machine learning and stuff. I was just wondering, like, if you give me some advice on getting to where you are, because I know that you don't really have anything like this summer for like first year students, but like,
well, so
is there anything that
do you want to tell me kind of where you are?
In your class specifically?
So it's a more kind of like what have you read about machine learning? Have you met around with any codes?
You know the CS231 and so I've been watching their lectures. You won't remember me, but I asked you a long time ago, what would you like recommend? I started going through that stuff. I haven't watched the whole thing. But like I'm slowly like, learning about it. But like I don't have any like direct experience with like machine learning yet. It's more so just like in a sense that I'm applying and stuff. Like, so have a lot of stuff with like I feel like programming. Like,
I mean, I would say kind of 231N has assignments. So I would see if you could do those. And it might be like it's like in 2016 it was a graduate class, which I think now it's mostly undergraduate. But like it might be that it's like a little bit steep to do the 231N assignments, but if you can, then that would be kind of the obvious next step. If not, you can. I don't actually have. So I have like 3 old assignments that are kind of like not as steep in terms of the climb, but they're kind of old. So you can go. So if you look for my 321.